Well, kids, here we are, Wednesday, April 1st, 2020. This is not an April Fool's joke. We are literally going to learn about science and specifically weather today. Yesterday, I gave you the atmosphere review and the atmosphere review quiz. Very briefly, if we flip over to that, I can see that 61 people have taken that quiz. That means that there are several of you out there that still need to take that. Keeping in mind that the deadline, Friday at 12 noon, no exceptions. If it's not in Google Classroom at that point, I won't be counting it, and it is a big chunk of what's going to decide whether you pass or fail science for this week. So make sure you take care of that. As you can see on the whiteboard of learning, the keyword is weather. And that's a fancy tornado that you're going to see. We won't talk about tornadoes today, but we will talk about them down the road. I'm going to try something different. I've got a Google slideshow here that I'm going to utilize to go through the information. I can tell you, and I'm also going to supply this to you, and that is the Chapter 16 PDF, which is the chapter on weather. Everything that I got that's in this slideshow today is from just these first couple of pages. So if you need another resource to look at, in fact, we're only going up to about right there today. So the first 4 pages or so in our introduction, but you'll have that in your hands probably before you have the video in your hands. So here we go. Weather. What is weather? By definition, weather is the state of the atmosphere at a specific place at a specific time. For example, if someone asks, hey, so, what's the weather like? We have to be very specific. We have to, if we're going to be true to the definition, where are you talking about and when are you talking about? So an example of that would be the atmosphere in North Fond du Lac, Wisconsin at 10:15 a.m. on April 1st, 2020. Then we can get down to what are those atmospheric conditions at that place and that time, and then we're talking weather. All right? Specific place, specific time. Now, weather describes such conditions as air pressure, wind, temperature, and the amount of moisture in the air. We're going to go over each one of those today. There will be a short quiz at the end of it. Maybe 5 questions. We'll see how that goes. But we're going to touch base on all of those right now. So here we go. Air temperature. Seems easy. At the bottom, you can see we measure it with a thermometer. You already knew that. You probably don't know what temperature is, though. So let's explain. Air is made up of molecules that are always moving randomly, even when there is no wind. They're just moving around. When the temperature is high, air molecules move rapidly. When temperature is low, air molecules move slowly. So temperature, and this is the mind blower here, is nothing more than the measure of the average amount of motion of molecules. Whoa. Here's what it means. If molecules are moving fast, the thermometer goes up. If molecules are moving slow, the thermometer goes down. So temperature is the measure of the average amount of motion of molecules. Wind. We studied that a little bit in our atmosphere section. Just go over the highlights on the slides very quickly. Air moving in a specific direction is the definition. Now this gets more into like what causes wind to go in certain directions. All right, so warm air molecules, as I just said, move quicker. That causes them to be less dense and therefore rises. Warm air rises. Cold air molecules move more slowly, which causes them to be more dense and sink. Warm air rises, which creates low pressure. Remember, pressure at the surface is kind of like a scale, and so when that rising air is going up, there's less pushing down on the scale. So rising air Warm air creates lower pressure. Cold air, on the other hand, is sinking, pushing down on that scale, creates higher pressure. Warm air, low pressure. Cold air, high pressure. Wind moves from areas of high pressure to areas of low pressure. So that cold air, when it comes down, it sinks to the surface, it hits the surface, and spreads out in all directions towards the areas of lower pressure. All right. Wind itself is measured with an anemometer, which is kind of that spinny thing with the cups that was in my classroom, had the red cup and the black ones, right? Or a wind sock, and there's other things that we use to measure wind. Of course, that would just be wind speed. Wind direction, the wind sock works for, a flag works for. Those roostery, chickeny looking things that are up on the corners of barns sometimes, those also work to tell us the direction of the wind. All right, humidity. Ladies in particular, but some guys also. How do you know when it's really humid? That's right. Your hair. It gets all frizzy. No amount of CFC-free hairspray or gel can keep that hair down when it's humid out. All right. Also, maybe you said, "Well, I sweat more," and that is also true. That's how we know it's humid outside. Now, here's what humidity is. It's the amount of water vapor that's present in the air. Water vapor, so water in its gas state. Here's how it works. Evaporated water fits in spaces between air molecules. Warmer air has more space between the molecules, and therefore it holds more water vapor. Cold air has less space and holds less water vapor. So humidity obviously is much more of an issue when it's warm than when it's cold out. All right. When the air is saturated or full of water vapor, saturated, think about a towel, a paper towel that's saturated. It's soaked up all that it possibly can. It will not hold any more. That's saturated. But when the air is saturated or full of water vapor, condensation starts. That gas turns, because it cools, it turns into liquid and forms droplets of liquid water. Also, we call those droplets of liquid water, as they're floating around up in the atmosphere, we call them clouds. All right. So humidity is the amount of water vapor present in the air. The higher the amount of water vapor in the air, the more humid that it is. All right. Relative humidity. This is what we always hear on the news if we listen to a weather report. They never talk about humidity. They always talk about relative humidity. And relative humidity is a measure of the amount of water vapor that's present in the air compared to the amount needed for saturation at a specific temperature. Warmer air holds more water vapor. So the actual amount of water vapor in the air depends upon the temperature. All right. So in other words, relative humidity is a measure of how much water vapor the air is holding compared to the amount of water vapor that it could hold. If it's holding 25 grams and it could possibly hold 50 grams, then the relative humidity is half, or 50%. It is holding 25 grams, it could hold 50, so 25 divided by 50 is 50%, or one half. I'm going to show you a chart on the next page, for example. We already mentioned a little bit, what do we notice when the relative humidity is high? Frizzy hair, we sweat more, it feels hotter, right? It's kind of miserable and the air is heavy. That's what we notice when we've got high relative humidity. What do we notice when the relative humidity is low, when there isn't much water vapor in the air? Well, if there's less moisture in the air than there is in our body, then the air actually sucks moisture out of our body. And what happens is we end up with dry skin. We end up with chapped lips. All right. So mostly we see those low relative humidities in the wintertime. All right. So here's the chart that I promised you. Here is an example question that could be answered using this chart. If the air is holding 20 grams of water, which is this line right here, amount of water vapor 20, right there, that black line. At what temperature would the dew point be reached and dew would start to form? Funky. We can't answer that question yet because we didn't talk about dew point yet. Dew point, the last of the 5 things. When do we notice dew forming? Mostly, we notice it in the summer months, in the mornings in particular, when we run out to get something in the yard that we left out that we shouldn't have, and we come back to the house and our feet are all wet. Or we hop on our bike to head over to the pool or to a friend's house and the bike seat's all wet. And we know it didn't rain. So where did that liquid water come from that made everything at the surface wet? That's dew. All right. And here's how it happens. When it's warm during the day, as we said before, air holds more water vapor. When it cools at night, the air can't hold all of that water vapor and it contracts. And as the air contracts and it can't hold as much of that water vapor, eventually it gets to the point that the air is full and condensation takes place and it forms water droplets. When that happens at the surface, it forms dew. So in short, warm days, cold nights equals dew in the morning. That water vapor condenses all over our bike seat in the grass. All right. Now the dew point is the temperature at which dew would form, and this depends on the amount of water vapor in the air, which means now I have to go back to this chart. So here is the amount of water vapor in the air. Here are the temperatures. The question says if there's 20 grams of water, at what temperature would the dew point be reached and dew would start to form? Well, you can see along here at temperatures 30, 35, 40 C, 45, 50, the air can hold all kinds of water vapor, 80 grams, and this one is 65 grams, and this is 50 grams, and so on and so forth. So we follow this 20 line. And once we get to, well, if it's 25 degrees, it can still hold 20 grams of water vapor. All right. But if we're down here in the 20 degrees, as you can see, the bar doesn't go up to the 20. It can't hold that much. So if the air is 25 degrees during the day, it can hold all that water vapor. If it cools down to 20, it can't hold all that water vapor and condensation forms and dew forms. All right, so that's just one example of a question that can be answered using that chart. Wow, that was a lot. In reverse, dew point, relative humidity, wind, and air temperature. All of those things go into what the things that weather can describe. All right. And again, weather is the atmosphere at a specific place at a specific time. There is going to be a short 5-question quiz that you should take after you've watched this. Keep in mind, I put the due dates for Thursday. You have until Friday, 12 noon to get that big atmosphere quiz, review quiz done, and to get this quiz done. All right. Give your best effort, and I'm sure your grade will be passing for the week, but I need to see that you're on there doing those things. All right. Again, any questions, email me, Google Hangouts, Google Meet. You know where to find me. And until next time, which is actually going to be a long time because I got nothing new for you until after spring break. So do your best and enjoy some time away from me. And we'll talk to you later. Bye.